Okay, I love this topic. This is C2 differentiation. It's stationary points. It's really common. Anyone know who this is? You'll find out later. This is a really common question. Find the coordinates of the stationary points of this curve. Okay, if you see the word stationary points, this is the clue in the question. They will also sometimes use the word turning points. And they'll also sometimes say they want to find the maximum point or the minimum point. So actually what we're interested in is we're interested in the place where this curve turns. Now you can see that the maximum turning point is here. There's the maximum. And the minimum turning point is here. All right, you can see those two little bits in there. So what I'm interested in finding is I want to find the coordinates of this point and of this point. Okay, so what I'm going to do is I'm now going to have a little look at the gradients of the tangent. Now, if I take a point on the curve and I do a tangent line, very bad one, sorry guys, all I'm interested in is the tangent, the gradient of the tangent, is it positive or negative? Now that is a very slight positive gradient. And if I did one here, it's a very slight positive gradient. The gradient of the tangent is still positive. The gradient of the tangent is still positive. The gradient of the tangent as it goes around the curve is now turned from positive to negative, and hence it's called a turning point. The gradient of the tangent is negative. It's negative, and as I move around this turning point, it changes from negative to positive. So that's why it's called a turning point, because it's the gradient of the tangent is changing. It's going positive, positive, negative, negative, positive, positive. Okay, but what's happening at the precise part of the turning point? So at the precise part of the turning point, can you see on here, at each bit of the turning point, the gradient is completely flat, it's completely horizontal. So it's not a positive gradient, it's not a negative gradient, it's a gradient of 0. So what we know at a turning point is we know that the gradient of the tangent at a turning point is 0. Like that or like that. And in fact, this one is called a maximum turning point, and this one is called a minimum. So my graph's getting a bit messy. Oh, I've done that wrong. Sorry, gang. That's not my minimum. This one is my maximum turning point, and this one is my minimum turning point. Okay, the minute that you guys see the word stationary point, what you're going to think to yourself is you're going to think about doing the bird. All right, so I want you to just think stationary points. We're going to do the bird. Where's he gone? There he is. Move him up there. Down there. Right, squeeze him along there. There you go. Birdie bird. Okay, birdie bird. Right, okay, so find the coordinates of the stationary points. We're going to, first of all, take that. Now, what you guys will do is you're going to draw a box around the Y. Now, of course, you might have to copy the Y out. The second thing you're going to do is you're going to draw another box. Let's see if I need a bit of space, where you differentiate what you've got. So if we differentiate the top, 3 times 2, 6x squared plus, the 2 will cancel to give 7x minus 5. Okay, so we're going to rub that a bit out. Don't need that bit there. Okay, so that's the next bit. Now the next bit you're going to do is that you are then going to do a second derivative known as d2y by dx squared. This is known as the second derivative. Notice how I say it, d2y by dx squared, and I'll explain why you need that later. So that just comes from me differentiating dy by dx. So 2 times 6 is 12x, and the differential of 7x is 7. Okay, what we're going to do now is we're going to write by the side what these things mean. So the top box is a y equals line. So what does that allow me to do? That allows me to find my y values. Pretty obvious. Okay, the second box is a dy by dx line. What does that let me do? That lets me find the gradient, come on pen, the gradient of the tangent. Sorry gang, sorry pen. Tangent, looks roughly. And the d2y by dx squared, I'll tell you much more about that, so don't panic. That lets me determine the nature. That won't mean anything to you yet, but it will eventually. So, it doesn't look much like a bird. Hey, no it doesn't, but it will in a minute. So what you're now going to do is you're going to take the middle box and you are going to set the middle box the gradient equal to 0. Now, do you remember in the last slide we said at a turning point or a stationary point, the gradient was equal to 0. So what I tend to find is that students will set anything equal to 0. They will often set the top one or the third one equal to 0 of the box. It's not the top or the third, it's the middle one that you set equal to 0. It's the dy by dx that is set equal to 0. And now, here comes your bird. So look at that. Da-na-na-na-na-na. Bird. Do the bird. There he is, there he is, there he is. Okay, in order to find the coordinates of the stationary point, what we need to do is we need to solve dy by dx equals 0. Okay, dy by dx equals 0. So my y function, which you've got, sorry, I've got it, haven't I? dy by dx. So dy by dx, I've got to set equal to 0. So I'm actually going to solve 6x squared plus 7x minus 5 equals 0. Now this will factorise. I've done it, so I'm going to just do it really quickly, and it will factorise to this. And therefore, the x coordinate will come out as minus 5 over 3, or it will come out as a half. Okay, now notice the question said, find the coordinates. Now, I often spell coordinates like that because there is a y in coordinates. And therefore, I've got the x values of the stationary points. I've got to go back and find the y values of the coordinates. So which of these 3 boxes gives me the y value? Bingo, it's this one. This one gives me my y value. So all I need to do is, I've got my x values, so my y is 2x cubed plus 7 over 2 x squared minus 5x plus 10, and so when x is minus 5 over 3, y is 2 lots of minus 5 over 3 cubed plus 7 over 2 minus 5 over 3 squared minus 5 lots of 5 over 3 plus 10. I'm getting bored of writing that out, so you can trust me if you like that I've worked that out for you. It's not a particularly nice number. It's 1015 over 54. And then, of course, I'd have to feed my x is a half into the y equation. And when I feed that in, my y will come out as 69 over 8. So I reckon, let's squeeze that up so I've got some space. I reckon the coordinates, notice there is a y in coordinates. The coordinates of the stationary point are, my x value was minus 5 over 3, and the y value was 1015 over 54, and the other coordinate of the stationary point was a half and 69 over 8. Okay, if we move him up a little bit out the way and we bring our graph in, does that look about right? Minus 5 over 3, that coordinate looks like it's that one, yeah, and a half 69 over 8 looks like it's that one. All right, so I have found the coordinates of my stationary points. Now, the last thing that you're going to be asked to do is you're going to be asked to determine the nature of the stationary points. Now, as well as being asked to determine the nature, you might be asked to classify the turning points or the stationary points, or you might be asked to say whether they are a maximum or a minimum. So here are our turning points here, and you guys can see quite clearly that this is this turning point, and he is known as a maximum turning point because he looks like that. And here is this one, and he is known as a minimum turning point. And life would be great if that's all we needed to say, but it isn't. Okay, so let's bring this back. Do you guys remember And where I've got y's all over the place, just ignore that. Do you guys remember that I said to you when we did this bit before here, I said there was another bit that we hadn't quite used, and it was this third bit here, where it says we're going to use the second derivative, or the second differential, to determine the nature of the stationary points. So what we're going to do is the following. My second derivative is 12x plus 7. So this is how we set it out. We write down that d2y by dx squared is 12x plus 7. And then what we do is we say, when x is one of the turning points, which is minus 5 over 3, so that's one of my turning points, we work out a value for d2y by dx squared. So 12 lots of minus 5 over 3 plus 7 equals, okay, I think that comes to minus 13. And because that is negative, we either write the word negative, or some people write it's less than 0. We make a decision about whether that is a maximum or a minimum turning point. Now, if you had to guess, would you say that was a maximum or a minimum? Okay, you'd all probably tell me it's a minimum because it's negative. It's actually, it's the way you think it shouldn't. So because it's a negative number, it's a maximum turning point at that coordinate. That coordinate is a maximum. Well, we knew that already, didn't we, via our graph? Okay, and then we feed in the second x coordinate. So when x is a half, d2y by dx squared is, we're feeding it into our second differential. It's going 12 lots of a half plus 7, which is positive 13. It's a positive 13, so we have to write that it's positive, or if you don't like writing the word positive, you can write greater than 0. Or in fact, you might even get away with saying positive, but you have to make a statement, and then is that a maximum or a minimum? It's, think of the way that it shouldn't, all right? So I would expect that a positive answer gives me a minimum turning point. Okay, so just to clarify, if we get a question that says stationary point, we are going to do the bird. So we are going to set ourselves up with one box with y equals, one box with dy by dx equals, where we've done our differential, one box with d2y by dx squared, and then we are going to do the bird by solving dy by dx equals 0, and then we should be fine. And the only last thing I'm going to leave you with is if they don't use a y notation, they use an f of x notation, then dy by dx is the same as f dash x. And of course d2y by dx squared is the same as f double dash x. So don't panic if they use an fx rather than y. Alrighty?